welcome to the CMS Summit 2024. I'm here to talk to you today about open chiplets and UCIe and how that affects storage and why that might be interesting to you. I'm Richelle Ahlvers. I'm the Vice Chair of SNIA, and here with me today is my colleague from Intel, Brian Ray, who also happens to be the Marketing Work Group Chair for UCIe. I have been working on a bunch of different things with a bunch of different consortiums, including crossovers between SNIA and UCIe. Our key industry expert here today is actually Brian.
Everybody, so glad to be here today. Like Richelle, I also work across different consortia, and UCIe is the latest of many standards that Intel is a big supporter of. So we're really looking forward to explaining a little bit more about it and how we think that there's some great opportunities for the storage market.
Thanks, Brian. All right, let's jump into it. What are we going to talk about today? Well, first of all, just to get a little exposure to folks, what is UCIe? There's a lot of new acronyms out there. So we'll talk about this one and dive in a little bit, give you an overview and just, what are these things? More importantly, let's jump into this a little bit more and say, great, that's a nice, cool technology, but why do I care? I'm a storage vendor. Why would I want to use these things? You're not a storage vendor at all. Maybe you're a consumer. So I just use these things. Why would I care if vendors are building these? Why would a chiplet-based system be of interest to me? Why would this help me? What about other standards? Why are we interjecting yet another new standard into the system? And how does this play with things that I already use? Is this going to work with everything else? So I'm going to hand this back over to Brian to give you an overview of UCIe.
All right, thanks, Richelle. Why are companies looking at chiplets? It's not exactly new. And in fact, if we really rewind the clock, the headlight on the train for the semiconductor industry for decades has been Moore's Law. The opportunity to put more transistors onto a chip, and then how do we leverage those transistors for different benefits? So adding new functions or putting more and more cores on a chip, reducing power, trying to do things within the same cost and power envelopes, et cetera, has been a tremendous benefit, and one that the foundry industries are carrying that torch and keeping it moving forward. But going back to Dr. Moore's seminal paper, it wasn't ever meant to be that there's only one way that an architect might decide to tackle their engineering problems and design problems. When we look at many examples in the industry today, there are reasons why you wouldn't necessarily want to put all of your technology on a single die. And so if we think about manufacturability, there are some physical limits, like if you have a really large design, reaching the reticle limit. Also, if you have smaller die, there's less, if something were to go bad, less chance that something's going to go bad. And so therefore, per wafer, you could potentially increase your yields by having smaller die. There are reasons why companies already might be looking, multiple reasons why they might be looking at, instead of putting everything on a single die, leveraging multiple die. The other reasons, could be that you've seen, could be the process. Do you want a leading edge process? In a lot of cases, because of the benefits of Moore's Law, you would, but there are other reasons, whether something's mature and so your technology isn't needing to take that leap to the next process node, or maybe you've got a process sort of optimized for something that you're doing, or you want to leverage a process where the costs are amortized, so maybe it's a lower cost process. You're making those choices of which is the right one for me. Well, if you're only going to produce one die with everything on it, then everything has to, you got to balance the needs of across the functions. But if you were able to break it up into separate dies and connect those dies, then you can say, okay, what's the best one for each one? There are a number of, whether it's just the replication of, say, putting multiple cores together, multiple dies maybe mirrored and put together in a package, or you've got different technologies like a CPU and an accelerator, or you want to stack high bandwidth memory on top of a processor. So lots of examples in the industry today that I'm sure everyone's aware of. what we're seeing as a trend. So as companies are looking at how do I, connect these die together and how do I package them, should each company go and look for their own unique solutions to that? Or even within a company, I've got different product lines. Should each product line go create their own interconnect? Or is there maybe a better way? So that's really the genesis of why companies, came together to form the UCIe consortium, is to looking for, the best in class common ways to create a standardized die-to-die interconnect. So UCIe was formed, a relatively short time ago, in March 2022. We made a lot of progress very quickly. We started with leading companies throughout the silicon, life cycle, from the foundries, making the die, to packaging OSATs, to IP providers, to the silicon companies creating chips. Having people from different perspectives collaborating and really thinking about it all the way from the end customer demand back to the root of creating the design gives us the ability to really think through all of the parameters that you want to make a healthy ecosystem for chiplets. So we have over 130 members now, and we have moved from a 1.0 spec to a 1.1 specification, and are working on a number of other exciting things in the future. And as we move forward, we still are going to anchor on some of the guiding principles that that we had in founding this standard. So as we see here, first of all, it's an open ecosystem. So we've got contributions from leading companies across the industry, and we're going to make a standard that when people invest in it from generation to generation, it will be backward compatible and evolve, and then leveraging the kinds of technologies that people have putting together systems today. You want these interoperable chiplets companies to be able to mix and match. And so you want a plug and play aspect all the way from how do you put the chiplets together to when I build the system, is it going to work as out of the box as you can make it. So we're going to continue also to look at the KPIs or the metrics that companies believe need to be in place to make UCIe the interconnect for die to die that they can count on. And lastly, there are issues across the considerations for building chips. So from electrical to packaging to system software, security. And so we have working groups that are looking at all aspects of what's important to keep a cheap chiplet ecosystem moving forward. The standard defines physical layer and also has form factor considerations, so that companies can think about how they're going to match up to chiplets potentially from different companies, or even if you're making your own, you've just got a standardized solution to draw from. So that's defined, and then kind of working up in the stack, there's a die-to-die adapter. And so, working up from there, you've got, protocol layer. And so this kind of goes back to, leading in from, where we want to leverage things that people are familiar with, or give the option for people to leverage where it makes sense. So if you're building a system today with add-in cards, then you're very familiar with PCIe. Of course, you don't have to do it as an add-in card. It can be a chip on a motherboard as well. And so there's, an architecture that's involved there, including behaviors for how things initialize and link up, and software on top of it. So the UCIe standard can leverage an optimized version of PCI and CXL for companies that want to build things that way. But we also have a streaming mode. And so if a company doesn't, they've got a solution that has a different standard protocol that makes sense, or even a proprietary protocol that could ride on top of the raw mode and the existing architecture. So again, it gives people flexibility for different types of designs, to go look at the things that you want to leverage, either from a design consideration standpoint, problem's already solved, or you want, the system behavior to behave like something that you're already familiar with, and or you've got a specific need where you need to do something a little bit differently, and you can do that. So then going up from the layers here, you'll notice that the protocol layer has a mux. And so what that can also mean is, let's say you wanted to use some properties of PCIe for the two chiplets when you power on your device or system, to connect and establish a connection. But then you've got another protocol that you want to use to do something. There's actually ability within UCIe to do both. And those can kind of go back and forth, if you will. So again, from a system designer, or as we'll talk about later, from an end customer point of view, this is really fueling the ability to innovate and to package different types of things, and to really leverage the capabilities from a system architecture standpoint to do some really new and exciting things. All right, so with that hopefully gives you an idea of why companies are looking at chiplets, how UCIe is helping to standardize the interconnect so that you can design and build SoCs based on chiplets. And so now we'll talk a little bit about what that might mean to storage. So Richelle, what are your thoughts on that? Is that exciting to you?
Thanks, Brian. So when I first started hearing about chiplets, I actually got really excited, because to me, this took a lot of the capabilities that we've been doing from system level. And I'm gonna date myself on this one, but shrinky-dinked. I mean, this is really the application of taking everything you do with composing systems today and took it down to the chip level. So let's talk about how you might apply that from a storage system perspective. If you think about building a storage controller, they really all have common building blocks. And disclaimer, this is not anybody's actual architecture. These are just some common components you might use to building a storage system. And this is really abstracted against whether it's an SSD or a RAID controller. There's really just some common components, right? They have processors, they have offload engines, they have encryption engines, they have out-of-band management, they have debug interfaces, they have cache interfaces, they have INI and OUTI storage interfaces, right? Something that goes to the backend devices, the backend storage, whether if it's an SSD, it's NAND. If it's a RAID controller, it's additional interconnects to the backend storage, SATA, NVMe, whatever, fiber channel, whatever kind of devices you got on the back end. And then on the front end, you've got protocol transport, and you've got interconnects. Right, so it's probably going to have more blocks in there too. Brian described these chiplet architectures. He talked about some of these same things already, right? He's talked about the UCIe architecture is built on PCIe, and I've got PCIe on here because PCIe is a very common interconnect for SSDs. A lot of commonality in these components and in the terminology we already talked about today. Now, when we talk about building controllers, SSDs or RAID controllers, vendors are already building these as custom ASICs. The SSDs are custom ASICs. You can go do a Google search and you will find block diagrams of vendors building their controllers using custom ASICs, and they'll say, special sauce here, or maybe they're building the whole thing as a custom ASIC, depending on the scale of the system, right? Building custom ASICs is not new. So folks are already doing a lot of custom work here. And what we're talking about is, how can we take this notion of leveraging what other people are doing for the portions of their system that aren't where they have their value add. So let me bring this into an example. What if we take an example of an NVMe PCIe SSD, where these things are largely, again, they're fairly small systems. They're primarily, ASIC based. Taking my previous example, I've taken like 5 of these components that are not where necessary, you know, they're fairly standard, right? So the PCIe 5, maybe the protocol layer is going to be NVMe. Okay, I want to have an SMB interface for out of band. I want to have a JTAG layer. I know I'm going to have a NAND PHY. I know I'm going to have an encryption engine. I know I'm going to have a DPU offload engine. So I've converted these over and said, okay, this is what of those various pieces. Here's how I'm going to construct my system. I'm going to have some processors. Now we've got our system, rough system here. All of these things could be chiplets then. So the question is, what chiplets do you want to implement yourself versus what do you want to buy off the shelf? If we convert this whole thing to a chiplet-based architecture, as opposed to a monolithic ASIC, we now have a lot of potential options to say, where's my value add? And this becomes then a vendor-based decision to say, we want to have our value add focused in specific areas. So, you know, I haven't mentioned this firmware block here, but I kind of did that for a reason. The primary reason is you could go to the extreme of everything except that, you know, special sauce in the firmware could theoretically be, you know, an off-the-shelf chiplet. And that really leaves it to you, to the vendor, to, you know, to you as an implementer to say, there's potentially the flexibility for someone else building all of these things. Go buy off the shelf. Like, unless you really have a super custom need, why are you going to go buy JTAG? You know, why are you going to go roll your own JTAG? Right? Everybody's doing JTAG. It's a debug interface. If somebody's got a chiplet out there or capability to, you know, integrate that, go buy it. You know, integrate it and focus your effort on your special sauce, which is maybe it's in firmware, maybe it's special compression, you know, maybe it's, you know, one of these other places. And then the other thing you have the flexibility to do in a chiplet-based architecture and the standards-based architecture is if you really do great special sauce around one of these other components, you can turn around and sell that too. So you not only can build it and put it in your own system, you can actually, you know, then you've generated IP that you could turn around and sell. But this is kind of the value of the chiplet. So we've talked about this a lot from the vendor perspective in terms of just how to construct a system and, you know, the flexibility and the architecture for that. This gives you an incredible ability to focus on the value add and the time to market. You really get to pick those off-the-shelf components. And we talked a little bit about this, so we put a little laundry list here on the right for you, just kind of think about built with standards already in use. Brian already talked about how UCIe itself is based in band and integrated on PCIe and CXL, but that's not it. That's not the entire list. There's a lot of things that, because that's based on PCIe and CXL, you get a lot of additional benefit. So PCIe alone gives you a giant additional stack. If you already have PCIe in your infrastructure, PCIe based anything in your infrastructure, if your systems are already PCIe based, you get to leverage everything there. If you have, again, going back to my PCIe and NVMe SSD example, you get the benefits of everything you've already built leveraging into that chiplet environment. You have that PCIe NVMe, you're doing basically the same standards inside, and for the internal communication protocols that you're exposing externally. So it's a simplification throughout the system. So you don't have a translation of different proprietary protocols inside and outside. So it simplifies your tool chains and your development processes because you're using the same protocols. So there's a lot of leverage points there. And it also simplifies, one of the things that Brian didn't talk about is manageability. Because those are in band, you get the manageability, integrated the same manageability because it's PCIe. You get MCTP, you get PLDM, you get SPDM in band, and UCIe has a working group, the security manageability work group, that is working to expand for the 2.0 or 2.x, I should say, versions of the spec to add, ability to do out-of-band management of chiplets as well, which will also enable standards-based management for the chiplet ecosystem. So there's a lot of additional standards to allow that integrated manageability. We've talked a lot about that little tiny manageability. All of those are enablers for redfish and for swordfish, that all of that forms the basis for that larger scale enterprise management, the enablement for redfish and swordfish, which you need that base standards-based management to truly enable that enterprise-based management that we all know and love here at SNIA. All of those things roll us up to faster time to market, faster technology adoption times. And a lot of that sounds like all of these last things are really not just focused on vendors. These are all pure customer values: faster time to market, built with more stable components that are leveraged into other products as well, standards-based management, and faster technology adoption times, getting products faster, getting new generations of products faster, more innovation, more leverage across standards. These are all the benefits that we can see from chiplet-based architectures, and how these would apply to storage architectures. So Brian, any additional points you'd like to make to that?
You did a great job, Richelle. So yeah, I mean, I think, coming back to UCIe and how we see this. So, you talked about sort of the opportunities for companies going forward. And so, there's tremendous opportunity, like you said, if when we have an open ecosystem, sort of a dream end state would almost be to imagine having Lego blocks. And so you go pull the Lego block you need and you build your chiplet. But that doesn't mean that, a company necessarily even has to, go that way. You've got the capability inside, and you've got your own whatever block that, we just talked about. There's still a ton of goodness in just being able to reuse that across different product lines. Back to the end customer, what that could mean is it makes it more efficient and easy for these companies that you're going to be buying storage products from, to maybe make a derivative SKU. So before, you have this one die, and if you wanted to go into a couple of different product lines, one die is going to have to fit all. Maybe now with some divisions, I put this and this together, and then now I just swap it out, and now I've got a different product by just changing one chiplet. Or I don't have to go reprove, that PCIe 5.0 block from product 1 to product 2. I'm reusing the chiplet. So I think that's going to give some innovation opportunities for the storage vendors that you're working with, that will be exciting for you to discuss with them, and what this means for being able to fuel innovation. Be as Richelle pointed out, the faster time to market, just being able to to keep pace with standards, and again to reuse what's stable, focus your energy on what's new and exciting innovations. The other thing that again, from a design standpoint, not having to work division to division within your company, or company to company, to spec out and test this die-to-die interface by building things on open standards that are interoperable within certain engineering reason. You can be comfortable knowing that these things are just going to work when I put it together. And so it's going to help ease that and that process and make things faster. And then lastly, as Richelle said about standards working with other standards, there are certain things that are compartmentalized. So if we do our job, things just work for people that are working on other standards. There are other cases where we'll collaborate across groups to try to do some best-in-class things. So there's a ton of opportunity out there, to make this a reality of an open, robust ecosystem of chiplets, and to keep advancing the industry.
We hope you learned a lot today, and we appreciate your attendance at the CMS Summit. Please take a moment to rate this session all 5 stars.